We're going to be studying parallelograms. This is the second section of 6.2. Okay? So before you write anything down, just watch. Just watch. Do not write anything down just yet. By definition, a parallelogram is a quadrilateral with two pair of opposite sides that are parallel. Okay? I'm going to show you a picture. Looks like this. All right? So let's talk about this for a moment. Don't write anything down. The opposite sides are parallel. So this one is going to be parallel to that. And this will be parallel to this. Opposite sides are parallel. Now it's time to start writing things down on your note sheet here. I've got colors on mine. You don't. That way you have, because some people don't have a way to print color, and you can write on it better. So what we're going to do is at the very top, I am going to write, the word quadrilateral here at the very top. Most of this chapter is actually spent on quadrilaterals. The reason I gave you colors is so you can, if you'd like, you can trace around the edges in different colors. We're going to study different kind of quadrilaterals, and most of this chapter is going to be spent on parallelograms. So I want you to draw an arrow to the largest of the boxes, and that box will be our parallelogram box. So I'd like you to write the word parallelogram in that box. I actually wish I would have written mine a little closer to the top. I like to have as much space as possible. You will write things multiple days for this, so just know that, okay? You can get another color if you'd like and draw around the edges of that box. By the way, every box on here is a parallelogram and is a quadrilateral at that, okay? I would suggest that you actually draw a parallelogram on there, and I would suggest that you actually, I didn't put it on here, but I would suggest that you write the marks for being parallel on it.
How much room do you think we're going to need throughout the...
I'm going to give you a statement, 4 lines of statements on this lesson, and then next lesson you're going to add some more, and you might actually have some formulas on that too. So I think you're going to be fine. I'm seeing your size of writing, and it looks great. Okay?
What box is small though?
All right. We're going to start reading our postulates. There's a bunch of postulates about parallelograms. We're not going to read all of them. We're going to read the even ones, part of the even ones, 2, 4, 6, and 8. And we're going to not write anything down on our paper yet, but we're going to read those. If you notice, 2, 4, 6, and 8 are if-then statements, and the ones right after them are what kind of statements? Converses. So we won't do the converses this lesson. We'll only do these. All right, Amy read 2 last time. The very first one up there. So can someone else volunteer to read number 2 for me?
Opposite sides of a parallelogram are congruent.
Okay, so now we know about opposite sides of a parallelogram. Someone else read number 4 for me, please.
Opposite angles of parallelogram are congruent.
Okay, so we know something about the sides. We know something about the angles. Let's do number 6. Would you read that for me, Brett? Thank you.
The consecutive angles of a parallelogram are supplementary.
We're going to talk about what that means in a little bit. Consecutive angles are supplementary. And number 8. Can I have a volunteer? Go ahead, Amy.
The diagonals of a parallelogram bisect each other.
Okay, so we have 4 things we just learned, all right? You don't have to write these down just yet. Just watch. All right. We just learned that in a parallelogram, the opposite sides are congruent. We learned that the opposite angles are congruent. We learned that consecutive angles are supplementary. Let's talk about that one for a moment. Consecutive angles are supplementary. If I had angle A, B, C, D, And if I told you that I had an angle right here, which one would be consecutive to angle A?
D?
D could be. What other one could be consecutive? B. The one right next to it. C is not a consecutive angle. C is a opposite angle. I haven't mentioned yet, I need you to realize that if you're ever naming a polygon in any way, you always go in order around, okay? So if I started with the letter A on this one, and I went this direction, I would name this one A, B, C, D. I would never name it A, B, D, C, okay? You don't skip around in any order you so desire. You have to go, so if I decided to start with B,
What about A, D?
and go backwards, which is so acceptable, it doesn't matter, but I have to go in order. I'd go B, A, then what? D and C. I would go
So I
in
wouldn't go B, D, A, C.
B, D, A, C. You can't go in a little X around wherever
so you
want.
can go C, B, A, D.
C, B, A, D.
That just sounds
Yes.
wrong.
I know.
Yes, it does. I think A, B, C, D sounds great. But so as long as you're going around in order, I want you to notice something really cool though. When you have a triangle A, B, C, you can never go out of order. Triangles will.
True.
So if I went A, B, you always go. You can't skip across to something else. Only on quadrilaterals and higher can you get like out of order. All right, now we're going to summarize what we just talked about on your note sheets. Oh wait, by the way, diagonals bisect each other. We're going to show you a picture of that in a moment. So here we go. Here's my picture of the opposite sides being congruent. Opposite angles are congruent. Notice the ones far from each other are congruent, not consecutive ones. The consecutive ones we just talked about being supplementary. Those add up to 180. The last one are the diagonals bisecting each other. The diagonals are the lines that connect non-adjacent vertices. So it has to, for quadrilaterals or parallelograms, they have to go straight across. Notice that when they bisect each other, that means it cuts both of them into two equal pieces. Not necessarily all equal to each other. We do have one longer diagonal than the other, but it did cut it in two equal pieces right there. Did I answer your question about diagonals bisecting each other? So that means that this point is the midpoint of both of them.
Yeah.
So this one, these little pieces are equal to each other. And this is equal to this.
It also cut them into 4 triangles.
It cut them into 4 triangles. All right, we'll talk about...
Will it always do that?
It will always cut it into 4 triangles. If you do both of the diagonals, yes. All right, now here Amy is answering your question. We're now going to write all this down. All right? In your little box, we're now going to write down that the opposite sides are congruent. I left a lot of space in there. You're welcome to scoot it up a little. I even saw some people writing their little diagram up to the side. Give yourself more room. What was after the opposite sides are congruent? What was the next thing?
Opposite angles.
Opposite angles are congruent. That's correct. Opposite angles are congruent. If you want to even put the symbols for the word congruent, please feel free to do that instead of writing the whole word. And the word angles too. We have an abbreviation for that. What was after opposite angles congruent? You guys remember?
Consecutive angles are supplementary.
Consecutive angles are supplementary. And you could even, instead of putting R supplementary, you could put equal 180. That would be a shortened version of that. Last thing, something about the diagonals. What do the diagonals do?
Bisect.
They bisect each other. So you could just say diagonals bisect if you didn't want to put the each other, but you do need to know that both of them, it cuts them into equal pieces. Both of them are in the middle. They meet at the midpoint. All right, we have finished all the information you need to know to be able to do this. So we're now going to move over to your assignment. Numbers 1, 3, 5, and 7 we're going to do together.
Wait, so is this just 6.1?
We'll have 6.
Wait,
We have one more lesson to do after this.
where?
So number 1, they want you to state all possible names for the figure. So the first thing you need to ask yourself, is that a parallelogram? Number 1. Okay, now I'm going to go back to the slide I had before. If it's a parallelogram, what else is it?
Quadrilateral.
It is a quadrilateral. So if you know it's the one below it, you're going to go up. So if it is a parallelogram, you have to write both parallelogram and quadrilateral.
It's also regular.
You could say that, but you only need to know the name of it. I don't need to know the regular or the convex or concave or anything.
Sweet.
Oh, so we're just saying all possible names. So I wrote it in a tiny little thing.
Yes, and it doesn't indicate that they're equal, and we haven't talked about squares yet anyway, and so don't worry about writing square, rectangle part. We just need to know parallelogram, quadrilateral. Number 4, what is its names?
Both again.
4 or 3?
Number 3 is number 3. Is it a parallelogram?
No.
How do you know it's not a parallelogram? Yes, and it doesn't show any kind of parallel, opposite sides parallel. Notice up here we had some opposite sides parallel here, so we knew it was a parallelogram. This is not a parallelogram, but what is it? Is it a quadrilateral?
It's a shape.
Yes, it is a quadrilateral. It is a shape. You were right. Number 5. Number 5.
Yeah, okay.
It tells us that this is a parallelogram. Find the measure of each indicated. The measure indicated. So we want to know this one right here. What do we know about, what's the relationship between these angle T and that angle R?
They're congruent.
How do we know they're congruent, not supplementary? Because are they,
Cut.
they're,
Diagonal.
they're diagonal from each other. These are opposite, yes, not consecutive. They are opposite. So angle R equals how much? They are congruent. 115. These two are equal. The opposites are equal. Unlike number 7 is the angle R and angle S, are they congruent?
No.
No, they add up to how much?
180.
So we know 70 plus 55x equals 180. 180 happens often in triangles, parallelograms, parallel lines. I'm going to subtract that 70.
Oh crap! Sorry.
Number 7.
All right, 110 divided by 55 is 2. X is 2. Do I have to plug it back in?
No.
No, I do not have to plug it back in. All right, let's do some more. I think there's more. Some more examples. Here we go. Number 9. This time I will have to plug it back in because it asks me to find W.
That's not nice.
So just make sure you know that you check that. Okay, angle W and angle Y, are they equal or they add up to 180?
Equal.
They're equal because they're opposite. So we're going to go -3 plus 9x equals 7x plus 11. I'm going to move the 7x over there and the 3 over there.
How do you plug it back in? We just gotta plug it back to what we're writing W.
Put
Just
the
W.
X value in
Okay.
for.
Yes, just W. What did you get for your x value, Brett?
7.
That's what I got also. Yes, okay, I just want to make sure. All right, now I'm not finished when I do that. Brett was right, I got to plug it back in. We're looking for W, so I have to plug the 7 in for that x there. So I'll have 7 times 7 plus 11. 49. Is it 60?
Yeah.
I need to get a different color, that's terrible.
That blue showed up.
Let's do 7 times 7 plus 11. That's better. And that, you said it's 60, correct? Degrees.
Yes.
All right.
The circle just
I know,
disappears.
disappear. Yeah, that's how I erase stuff like that. Take out stuff. All right. All right. Let's move, I think it's 13 next, is what I remember. No, 11 and 13. Now we're not going to talk about angles, we're going to talk about sides.
Hello there.
So number 11, what do we know about opposite sides of a parallelogram?
Congruent.
So the
19.
question mark equals 19. That is correct. Number 13. We now have a x in there. We're going to do some algebra. So how do I write this equation?
X plus 7 equals 16.
Yes, very good.
I'm done.
So 9.
I'm going to subtract 7, and I got 9. Yes. Do I have to plug it back in?
No.
No, because it doesn't ask us to find the measure of some side.
Oh, you don't.
Make sure you
Number
look.
15.
It could. Number 15 might.
Oh my God.
Number 15 does.
Why though?
All right, let's summarize what we've done so far. Please remember
You were done.
that a parallelogram has opposite sides that are congruent, opposite angles that are congruent, supplementary consecutive angles, or consecutive angles are supplementary, and the diagonals bisect each other. Are there any questions about these?
No.
All right.
Wait, what?